Hello everybody, welcome to this last video on the notion of functions, and we are going to devote that little 30-minute to composite and inverse functions. So what is a composite function? So a composite function is, generally speaking, when two functions combine to form a third function. Combine to form a third function. Okay, so this is not combined in the sense of plus or minus or multiply or divide. This is a new type of bringing functions together. Notation, and also explanation of what it means to be composite function. So notation, f, and then I'm going to put the little circle there. Looks like a small O, so that looks like a fog sort of thing, but it's actually read F circle G. F circle G is defined as f of g of x. Okay, so that's what we call a composite function. This is a composite function. Why? Because we replace a function g inside a function f. It is obtained, how do I obtain the function f of g? Well, as this terminology suggests, I'm going to replace everything inside f by g of x. But everything inside f are the x's. So it is obtained by replacing all x's in f. It is obtained by replacing all x's in f of x by g of x. So we'll replace the x in f of x by something else called the function g of x. That's what we call f circle g. That's a composite function of f and g. Right? So that's a new type of operation on functions if you want. How does that work on an example? Well, I got a couple that we could actually take a look at. So let's do this now. All right, so example 1. Let's say we have 2.5 stars to begin with. So let f of x equals 1 over x squared as my first function. And I'll take g of x to be root of x minus 1. Find f circle g. Find fog. Find f circle g. All right, so f circle g. By definition, this is f of g. Yes? This is f of g by definition. And we can certainly replace g with something because it's given. G is given to be the root of x minus 1. So I'm going to replace g by root of x minus 1. Make sense? Now, remember what we actually said f circle g was. this is like f of x, but the x is now root of x minus 1, right? So what if I ask you, what is f of 1? Go here, f of 1, where f of x is 1 over x squared. What's f of 1? Everybody would pretty much answer 1 over 1 squared, right? What is f of 9? 1 over 9 squared, right? What is f of bozo? 1 over bozo squared. Well, that's our bozo, right? So by replacing this into that, I'm going to replace all x's in f with this guy, root of x minus 1. So that's going to be 1 over, and I'm replacing all the x's in f with root of x minus 1. But the x is squared, so the root of x minus 1 will be squared as well. And there we are. This is f circle g. Of course, it can be simplified a little bit. The square of a square root, we all know, is 1 over x minus 1. Agreed? Good. All right. So take a look at Goff, little cousin of fog. G circle f till the turn these functions around. Are we going to get the same thing? Well, G circle f, what is that by definition? It is G of f of x. It is G of f of x. Agreed? And that is G of, what is f of x? It's given. F of x is 1 over x squared. So now the trick is to go into G and replace all the x's in G with this guy. Replace all the x's in G. What is G? G of x is a root of x minus 1. Root of x minus 1. Yes, that should be x in here. That should be x in here, but not anymore. We are replacing the x with 1 over x squared. And there you go. And there you go. You have here the composite function g circle f. Of course, this can be simplified a little bit. So we have here the root. If I take a common denominator, what will I have? Something over x squared. And then crisscross, I'm going to get 1 minus x squared. That actually is the composite function called g circle f. Now, when we talk about composite functions, we often want to find their domain. So, reminding you of the notion of domain, it's a set of x's that I can replace into the function without creating mayhem. So it's the set of x's I can put into a function such that I'll never get undefined as an answer. I'll never get the root of a negative number as an answer. I'll never get crazy shit, crazy stuff, sorry. So basically, what would be the domain of 1 over x minus 1? What are the numbers I can put in here without creating mayhem? The answer is pretty simple, isn't it? The only value that would actually force me to divide by 0 is x equals 1. So the domain is all real numbers except the number 1. Yes? Now here, this is a much more interesting problem in terms of domain because I have a square root. I have a square root in here. And not only that, but I have a quadratic equation inside the square root. Oh my God. So how do I find the domain of this? Well, the domain has to be something inside the square root that is positive, yes? The inside of the square root can never be negative. So I'll have to say that 1 minus x squared over x squared has to be greater than 0. That's got to be, otherwise the inside is negative and I have no answer. Now that's the same as 1 minus x, 1 plus x over x squared, right? Difference of squares. Oh, so how do I solve this type of inequality? Remember this when we saw inequality a while back? Oh, right. That was quite quite of an exercise way back when. Since the object here is more to focus on the functions themselves than the solving of the inequality, I will leave this to you as an exercise to find the domain of this function, that is to solve this inequality. I'll give you the answer though. The answer to this will be what? Minus 1 to 0 excluded. Minus 1 here, not minus nothing. Minus 1 to 0. Union 0 excluded, 2, 1 include. Actually, I can include the 1. So I'm going to change my brackets here. I can include the 1 and the negative 1. The 0 I cannot include because if I divide by 0, I'm going to get D and E. Does not exist, so that's not possible. Anyway, the passage from here to here is going to require some work. I leave this work to you as an exercise of finding the domain of a quadratic function inside a root. Good. So let's do perhaps something, again, a little similar and yet different. Let's do example 2. All right, example 2. Gotta get all the dust out of this thing. There we go. Example 2. Also 2.5 stars, if you're keeping track. Let f of x here equal x squared plus 2x. Let's have a g of x equal to 1 plus 2x. And let's have a third function, h of x, equal to x minus 1 over 2. Yes? Several things I would like to find here. So, find, let's try fog, f circle g. F circle g, by definition, what is f circle g? It is f of g of x, isn't it? It is f of g of x. Okay, we all know what that means. It means f of, what is g of x? It is given, no big secret. G of x is 1 plus 2x. What does that mean now? I need to replace all the x's in f with 1 plus 2x. All the x's in f. So what's f? F is x squared plus 2x. F is x squared plus 2x. See here, I would normally put an x, and here I would normally put an x. Not anymore. I'm replacing this x with the 1 plus 2x here. So I put in the bracket 1 plus 2x. Of course, I can simplify this. That would be 1 plus 4x plus 4x squared plus 2 plus 4x. So this would be 4x squared plus 8x plus 3. And that would be f circle g. G circle f. What is g circle f? It is g of f. All right, it is g of f. That means g of f. What is f? No big secret. F is given, x squared plus 2x. So, what is that? What is my g function? Here is my g function. It is 1 plus 2x. I'm going to say 1 plus 2x. But again, instead of writing x, because I need to replace all x's with a new value, instead of writing x, I'm replacing x with an open bracket, and in the open bracket I will put x squared plus 2x. X squared plus 2x. So of course I can simplify this a bit. That's 1 plus 2x squared plus 4x. And that is circle F. Notice that once again, these two are quite different from one another. Why don't we try G circle H? G circle H. What is that? It's G of H. What is H? Oh, there is this H, x minus 1 over 2. It is given. No big secret. It is given. So now I need to replace in G all the x's with x minus 1 over 2. What's G? Here's G. 1 plus 2x. Here's G. 1 plus 2x. Notice that instead of putting x in here, I put an open bracket. What am I going to put in the open bracket? X minus 1 over 2. I can simplify this a little bit, can I? 1 plus the 2's cancel, and that's x minus 1. Oh, look at that. 1 minus 1. This is x. I'm going to box this here, for this is an interesting answer, specifically in what's coming in the D part, where I would like to calculate HOG, H circle G, which is, what is H circle G? It is H of G. It is H of G. Now what is H of G? It is H of 1 plus 2x. All right. 1 plus 2x. And what is that? Well, once again, it means what? I must replace in H all x's with 1 plus 2x. What is H? This is H. No big surprise. It's given. It's x minus 1 over 2. H is x minus 1 over 2. But in the place of x, again and again and again and again and again, in the place of x, I will put 1 plus 2x. All right, let's see if that simplifies a little bit. 1 plus 2x minus 1, the 1's cancel. I get 2x over 2. The 2's cancel. I get x. Very interesting that both of these guys gave me the same answer. G circle H, H circle G. They both gave me x as an answer. And that is no coincidence, because we're going to see in a moment how these two functions are so closely related to one another. All right, let's go to the last notion, a function that we need to know for Calculus 1. All right, a little bit of this, get the dust off. All right, now, definition. F and G are, put that in capital, it's an important word, inverses of one another. Are inverses of each other, if F circle G equals X and G circle F is also X. Indeed. Notation. Notation. The inverse of F. The inverse of f is denoted f with a little -1 in the place of the exponent. And we got to be careful here with the notation, because we have seen before that x to the -1 is 1 over x. It's a reciprocal. This is not the reciprocal. When the -1 is applied to a function, it means the inverse of the function, not the reciprocal. So technicality, but we have to be aware of that. So f with a little -1 means the inverse of f. X to the -1 means the reciprocal of x, so 1 over x. This is not 1 over f. This is the inverse of f. All right? Now, in order to find the inverse, we're going to have a very simple strategy. So, strategy to find f inverse of x. So the strategy will be illustrated into 3 steps. Step 1, replace f of x with y. So instead of having, I don't know, f of x equals x squared, now you will have y is equal to x squared. Okay? Simple enough. Step 2, replace all x's, should go in a different color. Replace all x's with y, or y's, should I say? There'll be more than one. And replace y, and replace y with x. And replace y with x. So step 1, replace f of x by the letter y. Step 2, in this expression, all x's become y's, and the y becomes an x. And finally, this is where we do a little bit of algebra in step 3. We isolate y. This becomes our f inverse. Once you've isolated the y, you have actually found what is the inverse of f. What's the inverse of f? It's a function such that f circle f inverse equals x all the time, right? All right, so why don't we illustrate this with an example or two. Why don't we illustrate this with an example or two? What do I have here for you guys? I have example 3. Perhaps we should call this 3 stars just for the sake of the argument. 1, 2, and 3 stars. Find the inverse of, let's start with f of x equals 2 cube root of x plus 1. Okay, so we want to find f inverse for this function. So we're going to apply our steps here. So step 1. What is step 1? Replace f with y. So this f of x becomes y. Nothing else changes. So instead of f of x equals cube root of x plus 1, it's y equals cube root of x plus 1. Step 2. All the x's become y, all the y's become x's. So x is equal to the cube root of y plus 1. And now we need to isolate y in step 3. This is where we do a little bit of algebra. Step 3. How do I isolate y? Well, here's a y. It's in a cube root and it's added to 1. So the first thing I want to do is move the plus 1 to the other side. X minus 1 is going to be the cube root of y. I'm already a step closer. I need to find what y is. How do I get rid of a cube root? I cube both sides. I will cube both sides. Why is that? Because the cube root of a cube gives me the inside, gives me y. And there you have it. And there you have it. You've isolated your y, and that's your inverse. Conclusion. F inverse of this function is x minus 1 cube. That's F inverse. That's how you find it algebraically. Cool. Now let's do something perhaps a little more challenging. Where's my eraser? So find the inverse of this new function. Find the inverse of this new function. So b, what do we have here? What did I prepare for you guys? X minus 1 over x plus 2. X minus 1 over x plus 2. We want the inverse of this guy. Smudge, smudge, dust, dust, dust. All right, again, step 1. Replace f of x with y. So y is x minus 1 over x plus 2. Easy step. Step 2. What do I do in step 2? Who knows? What do I do in step 2? Replace all x's with y and the single y with x. So everybody becomes everybody else. X becomes y and y becomes x and x becomes y. So y minus 1 over y plus 2. Wow, I need to isolate y from that. How am I going to do that? Well, x is the same thing as x over 1. So let's cross multiply and see what happens. 1 times, so let's cross multiply those two. So 1 times y minus 1, that's going to give me y minus 1. Cross multiply those guys. What am I going to get? X times y plus 2. Okay, now I need to isolate my y from this. By the way, this last step could have easily gone into step 3 because it's algebra. Now I need to isolate the y. So what do I have here? I have y minus 1 is equal to xy. I'm foiling out here. I'm foiling plus 2x. All right, I got a y here and I got a y there. If you want to isolate the y, you'd be better off bringing all the y's to the same side. So y minus xy, brought this guy over, is equal to 2x, bring the minus 1 over, plus 1. Agreed? So, take out the y from here. What happens if you take out the y from y minus xy? You get 1 minus x equal 2x plus 1. And now we can actually isolate the y easily. Y is equal to 2x plus 1 over 1 minus x. That is your inverse. Conclusion. F inverse is equal to 2x plus 1 over 1 minus x. And that's the inverse of this function over there. And that's pretty good, yes. I will show you graphically on a Cartesian plane what it actually means when functions are inverses of one another, but I'll save that for class time because I've reached my half an hour limit for videos. So that's going to be it for today. And that's going to be it for functions. Next time we meet, we're going to tackle the last chapter of this course, which is logs and exponentials. In the meantime, you stay well, and I'll see you soon.